All right, here we go. So on the review, this is for our last exam. Sine, cosine, tangent, remember they eat angles. That's not really a math word, but the input is angles. And what their job is they spit out the ratio, right? That's your output. So like sine of 30 would go to your 30-degree angle and it would spit out the ratio of a half, which is what? SOHCAHTOA, opposite over hypotenuse. When you divide, that is the ratio you get, okay? Inverse functions do the reverse, right? So they eat the ratio and spit out the angle. Okay. So again, they eat the output. The output is what you shove into it, and then you go backwards and get the angle, which is typically what we think of input. But so in a sense, we're doing the reverse. So the input to these guys is a ratio, and then they spit out the output of the angle. So here my inverse sine is eating the ratio right up there and spitting out the angle. It's going backwards. All right, these are the two big guns, bow tie and unit circle, probably about 80% of trig. Those two things are just key, okay? Most of the time we use those. And then the next one is why are law of sines and cosines so helpful? Because you can find out all the info about the triangle, but you don't need a right angle. Okay, so in SOHCAHTOA and the bow tie, right, we are always in bow tie position, right? Meaning we always have to have it in that location with right angles in the corners, right? Now suddenly, you might have an angle that is, looking like that. You cannot put that in the bow tie position, but you can still do trig because we have law of sines and law of cosines. Okay, I'm going to pause. We'll do the next part. Okay, I notice there's a typo in there. You need to fix that. Put a little parenthesis. So it should just be the square root of 3 over 2, square root of 2 over 2. Some of you had issues printing if you're in my class. And so I got rid of the equation editor so that hopefully when you print, you can see everything because some of you have not been able to. All right. I think it's a good idea to think about what you're going to get. Inverse, this is a ratio, right? So I know my answer is going to be an angle, right? And so all you have to think of though is inverse sine is on the side. It is not defined there. So square root of 3 over 2 for the y value would be what? Right up here, half square root of 3 over 2. It's positive. So we're in quadrant 1, which is great. That is either a 60-degree or what? Pi over 3, whichever one you want to answer it. Okay. All right, here, inverse sine, again, is only defined on the side. So is inverse tangent, so is inverse cosecant. The cap up here is inverse cosine, inverse secant, and inverse cotangent. That's our problem child. All right, so we're over here, and we're what? Over square root of 2 and down negative square root of 2 over 2. So the sign here, okay, now you might be like, Julie, that's 45, or you might go all the way around actually and say, what, 315 or something like that. But remember, we have to have negatives here because technically inverse sine is only defined between negative 90 and 90, okay? So that's a negative, what, pi over 4. But notice this is going to spit an angle, okay? This is going to spit out an angle. The next function is going to eat that angle. So I actually don't even need to know what that angle is because it's not moving because it's defined here. And then that is going to eat that angle and it is actually going to spit out a ratio. So my input is a ratio and then my output's an angle. Now my angle's my input and my output is a ratio. And because inverse sine and sine are both defined there, I am just going to get the same ratio back. That does not always happen if you go to another area, okay? So that's just going to be the same answer, right? Negative square root of 2 over 2 right there. Okay, tangent of negative pi over 3. So that's right there. So what is that? That is over half and what? Down square root of 3 over 2. All right, so let's think about this. This is the input's an angle. That's what it's eating. It's going to spit out a ratio. And then the next function is going to eat that ratio or have that for input. And then my final output is literally just going to be an angle, okay? So I need to know this angle. Now inverse, so here tangent's defined everywhere. Now again, inverse tangent is on the side with sine, so that's good. So again, it's going to give me a negative pi over 3. So I'm going to be fine, okay? All right, so none of those had kind of a weird, weird scenario or anything like that. All right, I'm going to pause. We'll go to the next page. All right, here's the next page. All right, so remember inverse functions, the input is a ratio and my answer, it has spit out an angle. Inverse cosine is defined on the cap. And this is what? Positive, so, you know, we're good. There's no issues because inverse cosine and inverse secant are together up there. But again, if I'm going to change my function to something that's on my calculator, which inverse cosine is, the ratio is what gets flipped. We never flip an angle. We only flip ratios. So the ratio is going to be reciprocated here, so I can use it. So what do I get? 84.3 degrees approximately. I'm in degrees. You could do radians too. All right, let's do the next one. Now, this is the problem one. And the reason is because remember, inverse cotangent is on the side, but inverse tangent, or sorry, let me say that again, reverse. Inverse tangent is on the side with sine and what? Inverse sine and inverse cosecant. On the cap is inverse cosine, his buddy inverse secant, but also inverse cotangent. Tangent and cotangent are, you know, they're away from each other. All right, so let's just do this. Again, I'm going to switch to inverse tangent. I know the answer is probably wrong, unless I'm in quadrant 1. That's the only one that works for all. And again, it's the ratio that gets reciprocated. All right, so I'm going to do inverse tangent of what? Negative 1/5. And I'm in degrees. Okay, I get a negative 11.3 about. Okay, so a negative 11.3 degrees. That's here. Okay, see how that's not where it's supposed to be, because inverse cotangent is on the cap. This is illegal. But the nice thing about tangent is the same answers always slide straight across. I didn't draw that very well, but oh well, we're going to be over here. So that 11.3 that's here is the same 11.3 that's here. So I'm just going to take 180 and then back up a little bit. Okay, so 180 minus that 11.3 is going to get me that 168.7. So again, your calculator is going to give you the wrong answer because they think you're on the side and you're like, no, 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 I'm on the cap. You slide at 180, which is super nice with tangent. Okay, next one. Okay, let's think about what our answer is going to be first. Okay, this is a ratio, right? Okay, so this guy, the input is a ratio, and it's going to spit out an angle, or the output's going to be an angle. Then this one's going to have input of an angle. So my final answer is a ratio, okay? All right, so that means, and 1/5 is not on the, you know, unit circle that I've memorized, right? It's not like square root of 2/2 or something like that. So I am going to, this is going to be a bow tie problem, okay? All right, and it's not a calculator because number 1, I say exact value, and number 2, I say no calculator. And the fact that the final answer is a ratio, you're like, oh, I want a bow tie. Now, I am not telling you what quadrant to be in because I don't need to, all right? Because I'm telling you inverse cosine, you know that that is on the cap, right? These two are outlawed, okay? So, and then it's a positive cosine, so that means you're over here, right? So I know that I am over here, okay? Because that's the only place I can be. These guys are no-nos. All right, so what do I have? So toa, adjacent is 1. So hypotenuse 5, but definitely not to scale. You know that hypotenuse and a side, so this is Pythagorean theorem, but it's where you subtract. So you get 1 plus b squared equals what? 25. Subtract 1, I get 24. And 24, let's see, has, what, 4 is pretty, that comes out, 6, not pretty. Square root of 4 is 2, radical 6, okay. And it's a positive because I am going up, okay? All right, so now what? All right, so secant, here's my angle, theta. I don't even know what theta is, but see, I don't care because it's going to input the angle. It's not, my final resting place is not that angle. Secant, okay, secant is the flip of what? Cosine, well, I never moved. Do you see that? I'm in here, all right? And so you could just do like, okay, so cosine is what? Adjacent over 5, which we know, right? 1/5, 1 over the hypotenuse. And secant is the reciprocal of that. So it's just going to spit out the 5. And that should kind of hopefully make sense, okay? If not, secant is what? Cosine is adjacent over hypotenuse. This is going to be hypotenuse over adjacent. If you want to put the 1, you know, you can. Okay. All right. Let's look at the next one. Okay. Negative 75 is down here, right? Negative 75. Okay. Let's think about what we're doing here. The first thing, this is an angle. So that cosine is going to have an input of an angle. The output is going to be a ratio. then the inverse is going to eat or have an input of that ratio. And ultimately, I'm going to get an angle out of this deal. That is what's finally going to get pushed out at me. All right, so I need to know the angle. Okay, so let's check. Okay, cosine is defined everywhere, right? There's a x value and a y value. We know the x happens to be positive, right? We know the y happens to be negative. All right, so that's great. So this is going to spit out what? It's going to eat the ratio, the angle, and what kind of ratio is this going to be? We're doing cosine. So it is going to like this positive ratio. I don't really care what the sign is. Okay. Inverse sine is defined on the side. Yay. So we're okay. -75, right? Because we're on the side. So cosine's everywhere. Inverse sine is on the side, but that's legal. Okay. Because our inverse sine, you can't be here. All right. Let's do this next one, I guess. Okay. How do you solve every equation in the whole wide world? You isolate and do the inverse. So, and again, if you don't like doing these, you can do what we call as a U sub. And instead of cosine, just have u and solve it like a normal equation. But then at the end, you chose to have the u equal this, so you have to sub it back in. I don't usually do that. All right, I'm going to isolate my function. Here's my chunk. Isolate your chunk. So what is that? -4. Then you isolate the actual function. So divide by -4. So I get cosine of 4x equals a +1. Okay, if you do this, you're going to get u equals 1, okay, when you do the math. But eventually, again, once you get to there, you have more work to do. You have to do this. Okay, so now let's come up with the formula. Now, I should expect 2 because this is sine or cosine, right? So I'm going to write 4x and 4x. I'm expecting 2. If it was squared, I would expect 4 of them, right? And then where is cosine 1? All right, so let's think. So up here, let's see, this is what? 1, 0 on the x. This is -1, 0. So this is an example where I expect 2, but I don't get 2 because this cosine, the x value here is -1, right? And these guys are sine values. So I actually only get one equation. Great. Okay, what is it? Well, you could either put 0. I'm doing radians here. So 0 plus 2k pi, every rotation around. So I'm going to go 360, 360, 360, but we're in radians, so I'm doing 2k pi. Now you have to be careful. This 4 impacts the angle and the, like, how often it happens, right? It's speeding things up. So you go, what is this cosine? You go high, mid, low, mid, high, faster, okay? So you're going to have more answers down here. So I'm going to divide by 4, or you could use a fourth if you have fractions. So I get x equals, this is just 0, so I'm not even going to write it. 2 goes in there once. I get what? I'll just write half k pi. Okay, you could put k pi over 2. Does not matter. All right, what are all the answers in my domain? Now, normally I would expect 2, and if I'm speeding it up by 4, I would expect 8. Okay, but we only got 1, so I'm not expecting 8, but I'm expecting 4 for sure. All right. So let's see, when k equals 0, we just get 0. That's 0 radians, okay? X equals 1, sub in a 1 for k, I get half pi, or pi over 2. When, let's see, why am I writing x? How about k, and k? All right, so k equals 2. This cancels, right? Because I get a half times 2 over 1 times pi, so I get pi. And you can see they're going up by half pi, which makes sense, right? So when k is 3, 3 halves pi. When k is 4, and this says pi, 2 pi is included. So again, if you want to see me sub that in, half times 4 over 1 times pi, that cancels. I get 2 pi. Actually, I get 5 answers because the bracket is there. It's included. If this was a parenthesis, I would only get 4. But this is my solution set. Those are all the ones I get. All right, I'm going to pause here just because we're at the end of a page. And actually, let me pause it and graph it. Okay, if you look up here, I graphed the left and the right as 2 separate equations. And I'm looking for where they cross. Okay, so I just highlighted the 5 points and see how 2 pi is included. This one is 5 pi out of 2. It's out of my domain. And again, I made a video on how to use the wrench. But I went from like negative, I don't know, 2 pi or whatever, and to initially I just put 2 pi, I think here. All right. And then I did my stuff.